first of all, I want to talk about, okay, my clicker does not work again. Let's see. Why this topic is important to me. Usually, if newcomers come into an open source project, tutorials or getting started pages are their first point of contact. This is how the community presents itself to newcomers, to new developers, to the people we want to invite into our community. And now I want to take a sneak peek with you how we are welcoming newcomers to our community today. This is the top of our Getting Started page for LLVM. Here's the short story for getting up and running quickly with LLVM. Read the documentation, read the documentation. Remember that you were warned twice about reading the documentation. This is literally the first instructions that newcomers get if they want to get started with the LLVM project. I don't think I need to point out that this seems to be wrong, and we don't want to warn people to enter our community. Because if they read these lines that were written by the community, will they feel actually secure writing to the mailing lists, asking questions? Because you know, you were warned twice to read the documentation. Should you ask questions? Will you appear dumb if you ask questions? And I think we need to change this image that we're giving off. And I also thought we deleted this quite a few months ago, but apparently we did not, or it was rolled back, so we need to fix this after this meeting. I think this is the first thing we need to fix. And I want to elaborate a bit more about the two words I included in the title of this talk. First of all, beginner-friendly. Healthy open source communities need new developers to survive. Because people leave the community all the time, they move on to new jobs, opportunities. They change topics because they've done compilers for so long, they change to a different compiler. And if we don't want our community to die out, we need new people. It also is healthy for every company because we want a hiring pipeline that we can hire new candidates from. And yeah, I mean, the dev meeting is growing, so apparently we're getting new people. But if we're looking around the room, our community is not very diverse. We're doing good in some diversity statistics, for example, nationalities and location of where we're stationed. We're pretty good at that. But lots of other diversity factors, we're doing pretty poorly. So I want the LLVM community to also be more inclusive. And I won't talk about why diversity is important for software projects because there's extensive research and you can just use your favorite search machine to figure out what other people have said about this. This whole effort started with the LLVM Foundation's Women in Compilers and Tools workshop, or reception, or however it was called in the past. Because they were always voices, and we talked about, like, why is there so little diversity in the community as of now? And I've captured a few voices on the slides just to showcase why I started this effort, why I started thinking about how we could have more beginner-friendly inclusive tutorials. First of all, compilers aren't complicated. People are afraid of the topic even, because even in university, if you look at courses, it's like, okay, compilers, this is gonna be a really hard course, super hardcore theory stuff also. And I don't think that's necessarily true. Compilers are not that complicated after all. They are just a huge piece of software, and we make them sound really complicated. There's also limited opportunity to learn compiler concepts. Even if you happen to be lucky enough to attend university, very few universities offer compiler courses, and if you don't have access to university education, it's even harder to learn anything about compilers. There's a few books, but they're also expensive, so that puts a money price tag on getting into the community. And even if you happen to be lucky enough to learn about compiler concepts, that does not necessarily know you actually know a lot about real compilers, because we do know also our LLVM project diverts in some areas quite a bit from the theory that compilers teach at university. We do have existing tutorials and documentation. We do have the Kaleidoscope tutorial, for example, very famously on llvm.org, and other tutorials. But it is often really hard to follow those tutorials if you don't have someone next to you or in your vicinity that you can just ask questions to. Because maybe there is something out of date, and you have no idea how to replace that code bit, and you can't go on because it does not compile anymore, so how do you know that the rest of the tutorial is actually going to help you at all? And also, we like to omit information because it is so ingrained to our daily workflows that we forget that newcomers won't know these steps. Compiler tutorials also tend to be extensive. They tend to take a lot of time to complete. The kaleidoscope tutorial, for example, explains you how to add an entirely new language. It needs lots of files, and if you want to complete the entire tutorial, you need a lot of time to actually complete it. But most parts of the compiler actually don't need a week-long tutorial that you need to follow for you to be able to understand that specific component. You also don't need to add an entire language to understand one part of the process of doing that. But the bad thing about the tutorial is, if you haven't done the previous parts of a tutorial and just step into the middle and look at like, how do I do the parser, then you won't really understand because the context from the beginning of the tutorial is missing. And a working solution usually requires the completion of the entire tutorial, so even if you have edited some of the file itself might compile, but you don't actually see some sort of output because parts of the code that you need to write to complete the tutorial is still missing, so you won't see an actual output. There's also, as of now, no canonical place to look for quality resources for the LLVM project. There is LLVM.org that does have the kaleidoscope tutorials, some documentation sites, but really where you find the most valuable information is in some of the YouTube videos that were taken at the dev meeting, in some blog posts that very documentation-friendly people from the community have written, but there is no site indexing all of these. And there's also lots of not so high-quality documentation out there. And for a newcomer, it's impossible to decide where they should look first. What is actually addressed to them, what will help them get started in the LLVM community. So this led me to doing tutorial development. It has been an effort that's ongoing for about 1.5 years. It started with one of the Women in Compilers workshops where I started thinking about this. And I experimented with 2 tutorials over this time span. One is my First Typo Fix, which explains how you get into the LLVM community, how to submit your first patch, including all the community interactions that are rarely documented anywhere, how to interact with the mailing lists, what to expect, those kind of things. And my First Clang Warning, which introduces you how to add a new warning to Clang. It started with a hackathon-like week where we iterated with a small group on initial tutorial principles. So we had the topics for the tutorial set. We were just iterating on how do we want to teach this content. And after we had our initial setup, we then tried out what we had. So I also brought the tutorials to the Women in Compilers workshop, and we had a look at with other LLVM experts on the contents, and then we just tested the tutorials on our interns, on new hires that had little to no experience in compilers and the LLVM community. We tested on compiler engineers who work on different compilers and never had contact with the LLVM world, and also just on simple C++ programmers to see how well they would do with the tutorials. And iterated and rewrote parts of it, and so on and so on. And in the end, this leads to this tutorial on tutorials. And I also have a written up version, a meta tutorial on tutorials of this that will be uploaded sometime after the dev meeting. Now it's sort of a disclaimer. This talk wants to encourage you to contribute tutorials and documentation. This is an advertisement talk. Some talks say, like, contributions welcome. This talk says, please, please, please contribute to those efforts. If you want to write a tutorial, the first thing you need to think about is your audience. And as I'm talking about beginner-friendly inclusive tutorials, we'll assume that our audience, for now, is not someone who has worked in the LLVM project before. Of course, there will also be tutorials that address more deeply ingrained topics that will have a different audience. So when we first started this, we thought, okay, our audience could be compiler engineers. They have sort of an understanding of what we're doing. But then we thought about the compiler engineer term, and that's already a very limited set of people. So if we want to be inclusive and also increase diversity in our community, we need to look on a broader scale, which led us to say, okay, compilers are actually not that complicated if you only look at small parts of the pipeline, if you don't want to explain an entire compiler. but explain, in our example, how the warning system works. It's just a piece of software. You need to explain a few concepts for people to understand it, but it's fine. So we decided we'll make our audience the C++ programmers, which is already a more diverse set of people. And also for C++, you can actually find good open source courses and resources online to self-teach C++. Next up is choosing a topic for your tutorial. You have your area of expertise, and you want to explain this to your audience. Again, our example will be the warning tutorial for this talk. So I want to explain to someone how to write a warning in Clang. First of all, we, in the end, ended up using an artificial problem. I'll explain in a bit why an artificial problem and not actually a real programming challenge. We wanted this tutorial to touch the existing code base, because, Kaleidoscope does add a new language, but if someone wants to do something in the LLVM code base, to be honest, they usually don't want to add an entirely new backend or write a new language. They most likely want to do something in the existing code base. And there is not much information out there how to do that. And preferably a relatively stable part of the code base, if it's possible, because then your tutorial will likely not go out of date that quickly. It is also nice if the tutorial can be implemented in reasonable time. If you limit the scope of your tutorial to just your specific area of expertise, it is likely possible to find a problem that is reasonably completable within a day, or have intermediate steps that present finished results where some person can leave it off and pick it up at a later date. And in the end, the goal of the tutorial will be to enable beginners to do real contributions in your area of the code base, roughly. They could go on to the starter bug component and look for some bugs and see, okay, yeah, I recognize these classes, now I can start dibbling around on my own. So, choosing a topic for our First Clang Warning tutorial, we decided to do a complicated if statement. No one would probably implement a warning that tells you that your if statement that you wrote is complicated, but it does introduce you to various parts of the warning and diagnostics engine, so it's a good problem. So why an artificial problem? Those problems are constructible to teach selected parts of your area of expertise. If you want to demonstrate the use of certain classes, you want to show a specific component, the interaction with another part of the LLVM code base, you can choose a problem that needs to touch all those classes, that needs to have this interaction, and you can make the problem as artificial as you want, just to be able to showcase all those components you want to show. And if you know how to interact with those components, you can just transfer that knowledge onto other problems you'll tackle in the future. The good thing about artificial problems is also likely no one will actually contribute this to the LLVM code base. So it's not like you'll write the same thing again and feel like you're just duplicating code, or someone has written highly optimized code, because that's what we like to do as optimization engineers, for example. And those are much harder to understand, so there will be only your solution that you're implementing there. And the candidate that wants to join the community does not look at other code and feel like, okay, I could have done this way. Now I sort of feel, again, dumb. And the problem will be new to everyone. There's some well-understood problems in the compiler community. There are lots of resources on it, and it's nice to have a problem where you actually need to do some thinking yourself as well. And we're also candidates that also maybe come from other parts of the LLVM community, get into because they want to write suddenly a warning even though they've been working on backends. And also they will have to think a bit about it because they don't necessarily remember how to exactly do this, so they will understand the processes involved in developing this. So for the first Clang warning, we touched on different components. We touched on warning definitions, the diagnostic engine, nodes, fixits, testing, and we were able to do all of this with our artificial problem. So next up, now you have your topic, you need to structure the contents of your tutorial. We ended up with this 5-point structure. First an abstract, then problem statement and goal, instructions how to follow the tutorial, implementation iterations, and a summary, and I'll go into more detail of each of those steps. First of all, the abstract should be a rough outline of the tutorial. This does not mean you're already spilling the contents or talking about your artificial problem. It just tells you what techniques you're going to teach the newcomer. For example, this is an excerpt from our warning tutorial. This tutorial leads you through the development process of a new warning in Clang. We start from an idea for a warning, formalize it, implement it, and then test the warning on real code, finding bugs and false positives in our warning, which we fix. It's not like you need to hide anything from the person you want to teach something. You want to tell them what you're going to teach them. It's not like you're giving out any secrets. And then the second part, it should really have prerequisites and assumed knowledge. Because if someone starts following a tutorial and then they figure out they would need to understand some very complex thing first, they really would have done that probably before they started the tutorial, because then their tutorial flow gets interrupted. They learn about this new thing, come back, and it's just really frustrating to figure out later on that you should have done some pre-reading before starting the tutorial. So for our Clang Warning tutorial, we specifically stated this tutorial does not assume knowledge of compiler internals. We provide necessary explanations, and it goes on for a little bit. So next on the problem statement and goal section. Here we can go on to actually explain what we're going to do in the tutorial, explaining the artificial problem. What's also beneficial is to show an example what the solution of the problem would change in the code base, and I'll just show an example from our tutorial. We first showed a complicated if statement. We first defined it, showed the complicated if statement, and then showed where the warning would appear in the code. So the candidate can expect what they will do and what they will see once they complete the tutorial. Next up, instructions how to follow the tutorial. This is something that's very commonly overlooked. And this includes any necessary technical preparations, which could mean downloading any libraries, code, literally anything that you need to be able to just follow the entire tutorial without being interrupted in the middle of it, unless you intentionally want the newcomer to have some sort of workflow in between. This could include a checkout command, explanations on how to get the specific parts of your project, and it could also, for example, include a bundle of commits that apply the different stages of your tutorial to the code base in case the beginner gets stuck and really wants to start at some certain iteration of the problem. Now up to the actual core of the tutorial, the implementation iterations. We call this iterations because development is also, when we develop something, we also have an iterative process. We first dabble and find out where we need to do something, then we try some simple things, we make it more complicated, we make it more accurate. I wanted this to be reflected in the tutorial because this really teaches the person how to do this on their own. If we only present them the perfect solution in some sort of iterative way, we'll say, okay, you'll first need this function, now you need this function, now you need this function. This is not how we start. We start with some sort of combination of the things, and then we'll add more content to all of them as we go. So try to segment the solution into development iterations. Start with something really basic and simple. Iterate on that like you would do, maybe not exactly like what you would do in your development workflow. Make it even more iterations for a beginner. And finally, arrive at the final solution. And each of the iterations, for example, you could divide them by introducing a new concept, introducing how you use a new class that you haven't had in your implementation before. So the beginner gets a good flow of introduction. And what I think is most important is convey implicit knowledge, which means how do I actually find the file I need to work on? And the thought process to find the solution, not only say, okay, now we go to this file, but I mean, if the person wants to do something on their own, how would they find the file they want to work in? And how would they arrive at the solution? And also common pitfalls. Of course, they will encounter some of those in the code review later on, but still it's nice to at least, every development area has their really common pitfalls. For warnings, is always, you will always have issues with macros and templates. And if your examples don't include those, you won't figure this out until very late on. And this implicit knowledge really helps that people can complete the tutorials without outside help. Otherwise, it gets really, really hard. Just a brief overview of what we did for the Clang tutorial. First, we started with a simple dumping of if statements, warning on every if statements, adding a command line flag, printing warnings only if a command line flag is enabled, then actually implementing the logic, fix duplicate warnings, and fix a few more things that will go wrong if you don't do extensive testing. And within the implementation iterations, you can refactor out the conceptual documentation that you might need to explain to keep the iterations itself shorter. Also to have, if you have experienced people in the compiler community that also know compilers, they can just skip over this conceptual documentation and just see the flow of the implementation. And those links that you factor out into conceptual documentation can be reused by other tutorials. Also, very much appreciated links to external available documentation if you don't want to necessarily explain a specific concept like AST source location, you know a good blog post out there, just link to that. You don't need to duplicate or reinvent the wheel. And a very good thing to verify that what you did actually does what you think it does, test with a beginner. Maybe you have a new hire in your team. Someone asked you a question, you can just ask them, hey, I have this tutorial, can you take a look if you understand what it says? And then at last, the summary. And I think that's something that's very important to celebrate the successful completion of the tutorial because they invested a lot of time and they learned new skills. It's nice to actually celebrate that the beginner has completed the tutorial. Then summarize the learning process, which is essentially copying the first part of your abstract. You tell them again what they have learned, so they just reiterate over it in their head while they read that. And repeat the most important takeaways and implicit knowledge bits, because those are also the easiest ones to forget, but probably one of the most valuable bits they can take away from the tutorial to find around their own way in the code base. So what do they really need to remember if they now want to go on their own and fix a beginner bug? And encourage contributions. Now they actually know something. You can either point them to like more intensive reading, other documentation, then say, okay, now you're equipped. Let's try a beginner bug. Maybe you have a beginner bug component for your specific area, then you can link to that, or encourage contributions otherwise. And now onto one of the parts that is also very dear to me and good for documentation in general, not only tutorials, which is inclusive language. Because now we know how to structure a tutorial roughly, but what kind of language? Like, how should we write it? And I'm going to explain what I understand from exclusive language with some examples of 4 types of languages, which is compiler and LLVM terminology, encouraging language, neutral language, and easy language. And I'll deep dive into all of those. First of all, to have inclusive language, we need to be aware of compiler and LLVM terminology in our speech. Acronyms and terminology are one of the most horrifying entry barriers for newcomers. Because also if you're in a tutorial and in the first 3 sentences you hear 10 unknown words and no one actually explains them, and best of them, like 3 of them are like 3 to 4 letter acronyms where you don't even know what English words they want to convey, you're totally lost. And for us experts, it's really hard to imagine that we don't know those words. It's really hard to take the viewpoint of a newcomer. And we use acronyms and terminology all the time. It takes us conscious effort to notice what words we're using. But I would really encourage everyone, when you write tutorials and documentation, just take this effort. It will take you a bit longer to write everything, but take this effort to actually consciously notice when you're using terminology that's specific to compiler or LLVM. One solution to this is linked to the glossary. When you're using acronyms and terminology, we do have the glossary. At least when you first use this word, you don't need to link it every time. And optionally, if this word is really important to your documentation or tutorial, maybe introduce it in like 1 to 2 sentences. And update and extend the glossary. It's been fairly dead and it only contains very few words. So if you have like one specific class or word you're working on, go after the tutorial, just send a small patch that explains this very specific word you're working on. Then encouraging language. Engineers are really good at making everything sound super complicated and discouraging people at doing the same thing they're doing. This is really hard to do, super difficult to understand. Oh, this is so simple, obvious, you clearly need to do this. Yeah, if it's obvious, why do you actually write it down? Apparently it's not that obvious and a beginner should know this, and they probably didn't know before. This induces imposter syndrome, and you really don't want the newcomer to be discouraged and just stop doing what they're doing because they feel they won't be competent enough to actually complete the tutorial or to understand the documentation. Avoid telling your audiences how difficult or obvious you think something is, because likely you don't know their background and you might be wrong. And encourage your audience instead and believe they're competent. So if you wanted to say anything about difficulty or obviousness, just encourage them to go on. Next up, neutral language. And neutral can mean a lot of things. I'll just use some examples. Use gender neutral. If you want to refer to a specific person, use they, them. Don't assume gender. Be judgment-free. Avoid good, bad, right, wrong, because likely people will have done some things that are in the bad and wrong category, and they will feel judged. Culture neutral. Avoid cultural references and analogies. This goes to like some TV shows that explain something that maybe in your country everyone has seen, but you know, your country is not everyone's country. Background neutral. Avoid assume what people have done in their past. Not everyone has read the Dragon book, for example, so constantly referring to that to explain concepts, it might be awful for the people who have not read that book. Lots of people have not attended college, so they don't know the experiences you made there. Also, emotion neutral. Avoid use of adjectives and adverbs. Those in our documentation and tutorials don't actually usually convey any meaning. It's also the good, bad, right, wrong, hard, difficult. Those all fall in this adjectives and adverb category. A good question to ask yourself if you want to add an adjective or adverb in your sentence is, does this convey the same information if I delete that word? And in 99% of the cases, the answer is going to be yes. And this just makes your language more neutral and generally applicable. And last but not least, easy language. Many people don't have English as their native language, and even if they speak it fluently, they have deficiencies in vocabulary. So don't use overcomplicated words. We don't need Shakespearean English to explain compilers. Use really simple English, as simple as you can get to convey the meaning. So simple that even machines can understand it and translate it, because some people really do need this support. They might start reading the tutorial in English, but then they will turn on machine translation to really understand what you're saying. Avoid sayings, they don't translate well. Even if you speak English, the literal translation of a saying will most likely not say what you wanted to say, and avoid slang. It's really hard to machine translate. Yeah, thank you, and please contribute. And I think we have time for a few questions.
Thank you very much, Meike, for this presentation. And we have about 2 minutes, and then it's a break, so I'm sure you can grab Meike also after that. But if anyone has questions, I can bring the mic to you.
Hey, thanks, that was super useful. So a couple of questions. LLVM's documentation right now is, I believe in order to actually change anything on the docs, you have to, like, it's part of our Git repository, so you have to put up a patch essentially. And for newcomers, sometimes, like, maybe there's a typo you want to fix, or like a link that's slightly broken, or some setup that's specific to your operating system. Are there like any plans, or do you have thoughts on like any way to lower the friction for people to contribute?
Yes, absolutely. We have discussed this quite extensively on Monday in the Women in Compilers and Tools workshop to like figure out some alternatives, to maybe use a wiki-style way to have our documentation. And we'll work in the coming month to figure out a way to how we can lower the friction of contributing.
Cool, awesome. And also, like, you mentioned trying to use neutral language as much as possible, which, like, specifically, like, avoiding value judgment, which I understand. At the same time, there might be, like, integer roles, so, like, maybe you want to encourage or discourage, like, certain code patterns, or, like, there's certain ways of doing things which are, like, not advisable. So, like, how do you recommend, like, talking about that?
Something you can always say is there's a preferred way to do it.
Okay.
I think this is like one of the words that can be used best. Also
Sure.
not say like this is the terrible thing to do, just tell them this is the preferred way to do it.
All right, awesome. Thanks.
All right. If no one else has a question, I'll keep everyone here for one more minute for my question. Nope. Perfect.
Yeah, and I'll just say I'll have a roundtable on improving the documentation we have after the break, where we'll have some hands-on session, and there will be someone who stamps all the commits so we can get some of the non-inclusive language out of our existing documentation.
So you made a point to say that don't state value judgments on how hard or easy something is, which I thought was a very good point. How do you balance that with like keeping people who don't understand something that is legitimately hard from feeling like they're missing something that's maybe normal or something?
First of all, if you think this will be really hard, try to break it down even more. Use an additional iteration, break the concept down into smaller pieces. And you can also say, it might take some time to complete this iteration, but I really want to encourage you to keep at it. So encourage them instead and say, yeah, it might take some time, but I'm really sure that you'll benefit from completing this, and just break it down into as small pieces as you can.
Okay, so the break is here, so thank you very much again, Meike, for the presentation, and thank you everyone that came to listen.